All right, section P.3 is rational exponents. So the first place that we're going to start is a notation that you are familiar with, at least some of that, in radicals or square roots, right? Square roots are the ones you're most familiar with. That's the second one that's listed here. But radical is a more, well, it sounds funny to say this, but it's a more generic description. Okay, it's radical. Like cool, right? Cool stuff. Okay, the first one, what I want to show you on this section is that you can rewrite these as exponents. In particular, the nth root of a can be written as a to the power 1 over n. Now, square root doesn't sort of look like it has a number right there, like the n was. But what's the number that's really there? It's a 2, hence the word square root. Okay, it is a 2. So there's an understood 2 here, which means that it can be written as a to the 1/2. So if I can take these radicals and I can rewrite them as exponents, then all the properties we just did in the last section for exponents work. Because this is just another way of writing exponents, right? So as we take a look at the properties on this particular slide, you're going to look like, well, I think I already did that. And the answer is, yeah, you did. Okay? So take a look at this. It says the nth root of AB. I can change that to being the nth root of A times the nth root of B. And that's actually the exponential property that we did in the last section, kind of written backwards. We started with something that looked like a to the m, a to the n, and then we took the m and the n and we added them together, right? We had something that looked like that. We had a property that looked like ab, this one's the one that looks most like this, to the m, and we separated it and said I can write this as a to the m, b to the m, right? These are those same properties at play here. We don't need this in this slide, but that's what's going on, those properties, okay? The second one, if it works for multiplication, I know you probably won't believe me when I say it, but it's going to work for division because really multiplication and division are the same thing. They are the same thing. So I can rewrite this, just like the other one, as the nth root of A divided by the nth root of B. So what does this do? Like, why do I care? Well, this allows you to simplify radical expressions. That's what it does, because it allows you to break things down and to isolate parts that have perfect squares in them. Now, the first couple examples that we're going to do are going to actually have perfect squares in them, okay? So we're not going to need the properties quite in their fullest potential right off the bat. But as we continue to work, we will need them more and more. So let's take a look at just a couple of examples for today. The first one is 1/4 to the power 1/2. So, how else could I write the power 1/2? Square root. So this is the square root of 1 over 4, like that. But property number 2 on the last slide said, how could I rewrite this? Square root of 1 over the square root of 4. And maybe I just think it, and I don't actually write it. Either way, I end up with a radical of 1 on the top. So what is the square root of 1? 1. And what's the square root of 4? 2. That's 1/2. The square root, or the 1/4 to the power 1/2, is actually 1/2. All right, take a look at the second one. Negative 144 to the power 1/2. There's that negative going on again. Where's the negative? On the outside. Don't deal with the negative. If it was supposed to be on the inside, what would it look like? It'd be in parentheses with the 144, right? So it is not going to actually affect the processing of this problem. It'll affect the answer because it's going to be there, but it's not going to affect how we do the problem. We do, in fact, still have a square root here because it's power 1/2. So I have the square root of 144. Do you remember what the square root of 144 is? It's 12. So this ends up giving us a negative 12. Any questions on that? All right, that's where we're stopping for today, guys.